Welcome to our continuation of section 5.6. In this video, we're going to be investigating why at asymptotes our function shoots up to plus or minus infinity. And we'll be doing a case study with this function g of x equals x divided by x minus 1. And it'll also provide us into some insight about end behavior as well. But for the moment, we're going to talk about asymptotes. So if you remember, there's a couple things that we wanted to know about our function. The first was its domain, then its roots, then the y-intercept, and then asymptotes, which are kind of fundamentally connected with the domain, because where the points where we don't have something under the domain, that's where we get an asymptote. So remember, our domain is just the points where we aren't dividing by 0. So we write it as all real numbers minus the points where we are dividing by 0. So we're taking the points out where it gives us division by 0. For g of x, take a second, pause the video and think about what it is, and then come back. Okay, hopefully you found that it's all real numbers except 1. If we plug 1 in, we divide by 0. We can't have that. Our roots are just where the top is 0. So our roots are just x equals 0. Our y-intercept, if we plug in 0, we get 0 divided by -1, or just 0. And we get an asymptote where the domain does not contain, for the points on the domains, we get an asymptote at x equals 1. And more formally, this is a vertical asymptote. We call it vertical because it's straight up and down. And that'll be an important distinction later on in this video when we introduce an oblique asymptote. All right, so we'll start to draw our graph. We know we have an asymptote at 1. And we have an x and a y-intercept at the origin. All right, so we want to think about what happens when we're getting close to the asymptote. So there's a couple different ways to write it, but let's just start off with what happens close to the vertical asymptote. Write it in limit notation. The limit as x goes to 1, we do this little negative from less than 1 of f of x. Or we can write it as x increases to 1. So we're kind of thinking about what's happening as we're moving in this direction. Is our function going up, or is it going down, or is it possibly just going right through? So we'll leave question marks on that for right now, and then below we'll investigate it. We can think about if we have x over x minus 1, and we plug in something just a bit less than 1, like 0.99. Then we get 0.99 over 0.99 minus 1. So this top 0.99 is about 1. That's not going to change too much, but this bottom is negative 0.01. So it's something pretty close to 0, and it's negative. So we can think about this as actually just being -1 over 0.01, or -1 divided by 1 over 100, which is negative 100. So already we're getting a pretty big value out. And that's because we're dividing by something close to 0. So one way to think about, I think something that students think about often is that 1 divided by 0 should be infinity. Turns out it doesn't always work, but it kind of works that way. If you go on to higher maths, you can study something called the extended real numbers, where there is division by, not by 0, but infinities in there. And you can sort of think of division by 0 in that sense. And it's because we're looking at division can be thought of as like splitting something up into a number of parts. And so we have to split it up into so many parts that we get like 100 out of it. It would tell us we need 100 parts to split it into, which is quite a bit. If we plug in an even bigger number, like 0.9999, then the top is even closer to 0, but the bottom, or sorry, the top is even closer to 1, but the bottom is even closer to 0. And we actually end up with, that's approximately negative 1 over 10,000, or negative 10,000. We're getting these really small, these really large values out of it when we're just plugging in things close to 1. And so it turns out that we're going to get that our function is going to look like a curve that goes down like that. And thankfully, nothing wacky ever happens with these graphs. Like the pattern's pretty well behaved. So between 2 roots and an asymptote, it's enough to just check the sign. In our case, we would have checked and found we got negative 100, so that tells us it's a negative. So it has to be going down in the negative direction. We can actually use our sign trick for the other side as well. You know, when we were graphing polynomials, we were talking about if it's an even or an odd degree, if it's going to change signs or not. This is the x minus 1 is an odd degree. And so this sign actually flips, and we get something that looks like this. So those are our asymptotes. And the last thing we want to check now is what our end behavior is. And this one's actually pretty interesting. Because we have x and x minus 1, our end behavior, it doesn't go to 0, and it's not going to infinity as we plug in really large values. Actually, it turns out that as x goes to plus or minus infinity, g of x approaches 1. And let's see if we can reason out why that's true. The gist of it is that it's kind of like what we were saying before, where when we're plugging in really large numbers, we actually don't care that much about this minus 1. So like 1,000,000 over 999,999 is pretty much just 1. It's 1 plus 1 over 999,999, which is a pretty small value. So what we do is we draw in a little dotted line at 1. Call that 1. And then our function just kind of stays on the side right above it. So it goes almost constant just to 1. And the same thing happens on the other side as well. But now we're just staying below that 1. Because if we plug in a negative value, like let's say -10, so g of -10, get -10 over -11, which is just 10 over 11, so something slightly smaller than 1. Whereas on this side, the million over 999,999 was slightly bigger than 1. And so that's what our graph looks like. All right, so we're going to need to do a lot of practice with these. None of these functions are necessarily hard to graph, but because there's so many different moving parts, students can really struggle with them. In particular, I find the best way to approach these is to write down the like 6 or so things that you need, and then try and get those one by one. And then these kind of just boil down into like 6 mini math problems that you're solving instead of just one big math problem. All right. And the last thing, just for terminology, throwing this right in at the end, but this line across is known as a horizontal asymptote because it's horizontal. In future videos, we'll also see oblique asymptotes, which is when the asymptote isn't horizontal across or vertical up and down. All right. Signing off now. But yeah, please just try to get in as much practice with these as you can.